So a little bit background about myself. I've been working with Code Fusion for over 8 years now. I'm from Northern Virginia. I work for a company called ICF. And I'm available on LinkedIn and Twitter. So agenda for today is we'll briefly go over unit testing concepts and we'll look at the demo examples using TestBox and Knockbox. And then we'll go over JMeter Introduction and demo. So first of all, why did I select this topic? So as you all know, we do have this yearly survey by Ghotikar. It's called State of the CF Union Survey. And for the last 3 years, as you can see, when the question was what testing and mocking frameworks do you use, we can see like some percentage we do have, like some people use MXUnit, Selenium, Knockbox, TestBox or other, but then there's a big 54% of chunk that still don't have any of the frameworks in place for testing, and where this is quite a lot of percentage in 2019 as well. So as you can see, there's still not many people that don't do or don't have these kind of frameworks in place. So that made me think we do have these kind of tools available out there which are open source free and that they are simple to use. Then I should just put up something and give a demo of it. Like, even if you take it a little bit from the presentation, like how do you install a TestBox, Knockbox, and how do you get started with it, that's a big thing. So what is unit testing? If you all attended Gavin's session earlier in the same room, he spoke about unit testing and integrated testing. So unit testing is a level of software testing where individual units or components are getting tested, and when we test them, we are testing them in isolation. So if there are any dependencies, we mock those up. So having said that, the unit tests are like, we are testing methods in the Code Fusion component, and they are of low level and they are of small scope. So why is the unit testing vital? So let's say if we don't have any kind of unit testing in place, and we don't even have any integration testing in place, then when we deploy our code to production, for that matter, even their development environment, we'll do our manual fuzzy testing. Like we'll open the browser, fill up the forms, hit submit, and that will possibly hit our code base. But this is like a very tedious process because any small lines of code change and you have to repeat the entire process over and over again, which is time consuming and you may not cover all test cases every time. So that's a big drawback. So if you have your automated unit testing in place, you can set up a Jenkins pipeline, and on each build you can run this unit test, and if something fails, you will know right away what needs to fail. So they give us instant feedback, and because of that, it increases our confidence in any kind of when we are changing the code or when we are maintaining the code. When we are writing the code, since this is unit testing, we try to break down the big functions into smaller chunks as much as possible. So we end up writing modular code, and that's why it's more reusable. So it can expose the hyperlink, and that's a big plus. Because of that, refactoring gets faster because you know the feedback right away, and at the end of it, we end up writing better quality code. So, what is TestBox? So TestBox is an open source project developed by Artist Solutions. It's available for free and it's very easy to install. So if you just go to this website, Artist's website, if you are already using command box, it's just one command to install it. It's box install TestBox. You cannot see this. Okay, if you're using command box, it's very easy to install. But even if you're not using command box, you can just go to their Git repo and check that out. And once you install it, it installs a TestBox in a folder called TestBox. So it's right here. Yeah, and then the second thing to note is that you have to run this command to generate the hardness for it. So that's it. It's just 2 simple steps, and you're all set up in TestBox. I don't have a demo for that, so I'm not sure, but it's very simple to install. Next thing, what we'll do is yeah, so main thing with TestBox is it supports MXUnit style of testing and as well as PDD style of testing. So we'll look into the examples of both styles. So speaking of which, let's first quickly go over the TDD. So TDD is the test-driven development. So as a developer, we think from the code perspective first. Like we just write the code and then we think, okay, I'll come back to this and write the test later. But that usually doesn't happen because of various factors. Like your project may not have enough funding to write the test, or in the timeline, your project is very on tight schedules and you may not have time to write the test. And there are various reasons for it. But in the test-driven development, it's the other way around. You write the test first and then you write the code. So it's like a reactive program. So we start with the red circle there. We write a test, and since there is no code yet, when we run the test is going to fail. And then we write just enough code to make that test pass. If the test is not passing, we'll still write some more code to make the test pass. And that cycle would repeat until our tests are passing. And once the tests are passing, we'll just see if there are any opportunities to refactor the code. And if yes, we'll just clean up the code, refactor the code, and then the entire cycle repeats. So that's like a red-green refactor. Red means where tests are failing, green means tests are passing, and then we refactor. So that's the TDD way of it. So I'll have a quick demo for that. How would you do the test-driven development? So this is my test written using the MXUnit format. So it's a very simple test of concatenation. I'm just concatenating two strings 1 and 2, and then I expect my result to be 1, 2. Same thing here, I'm concatenating 1 and 3, and I expect my result to be 1, 3. And then on these lines, I'm asserting my expected outcome is same as my actual outcome. Same thing here. So these are my 2 test cases for concatenate function. And then the first line is extending TestBox's system-based specification. So what does before test is? So this is a global lifecycle method. In this thing, I'm just defining my target, which is also called as system under test, SUD, or component under test, CUD. So I'm just instantiating my CFC, the code fusion component. And now when I run this test, so I still haven't created my CFC yet. So we started with that red circle. We wrote the test first. And now when I'm running the test, it fails. It says cannot find component controllers.demo1. That's fine because we expected the test to fail. So now I'll go ahead and create my component. So that's my component. I have created my component. Let's say I don't yet have my function in place. So I'll go ahead and run my test again. Now it says component exists but has no function name in concatenate. So we are reiterating over that red to green circle. And okay, so I'll go ahead and now create a function. Let's say I don't yet return anything. I just create a function body. Now what happens when I run? It says variable actual doesn't exist. That is because my function is not yet returning anything. And now when I actually return something, my test will pass. So that's the TDD way of writing the test. You just write the test first, it fails, now you just write enough code to make it pass, you run it again fails, you write some more code, and you do it until the test passes. Since this is a very simple example, it doesn't have any opportunities to refactor, but you get the idea. That was MXUnit style of testing. Like as you can see, it doesn't tell much like what's happening here. It just says the test is passing and then it just the test that's it, but you don't know what can be happening. So that's the limitation of TDD. It is first of all very much developer oriented. It can become very tedious to think from this perspective, like, okay, I'm writing the test first, but I'm focusing on deep down at the functions level and I don't know how to test or where to start. So these are my first two questions, where to start and what to test. And the third important thing is we are not focusing on what the system is doing, rather we are focusing on how the system is doing, like how we are implementing stuff. So it doesn't verify any of our expectations or stakeholders' expectations. So to overcome that, Dan Norton came up with this concept called BDD, which is behavior-driven development. And I would strongly recommend you go ahead and look up that link. It has a very great introduction on BDD. So as also Ghotikar mentioned earlier in this session, in BDD we are focusing on user stories now. So we are now focusing on what a system should do and not how it should be implemented. So it is an evolution of TDD. Like we would still write a test first. It's still like a reactive programming, but we'll think from the function behavior, like what the system is doing. And with that, we'll end up writing vendor readable test. And it also verifies that we are meeting customer expectations. So coming back to the earlier example of concatenation, let's look at how we would do it using BDD style. So my tests are still the same, but written now using BDD. Okay, so here now I'm writing my test using given when then format, where given is my input or preconditions before the test. So I have two input strings. When is my event or function that's getting implemented. So when concatenate function is called. And then is my host condition. That's where I'm expecting something that the system should do. So I'm expecting my concatenate function when 1, 2 arguments are given, it returns 1, 2. And same thing with 1, 3. And that's the scenario. So you end up writing tests using user stories and scenarios. Again, similar to before test, we also have before call function where you will define your system under test as CFC. So what happens when I run this test now? Okay, so now it has given me a nice little output, like this is my scenario, this is my given when and then. So if you have a real world scenario, you would end up writing your user story on the first line, and you would have all your conditions, like this was given, this was given. And this is like better readable, and you can also verify that your customer expectations are met. And as you can see, all the unit tests are running in milliseconds, so they are very fast because they don't have any dependencies outside the database or file systems or network. So they are very fast because they are very much isolated. So that's how you write using the BDD. Coming back to slides, let's just quickly go over this is Ghotikar article. So in Agile, we will start with the user story, we'll break down this user story into scenarios, and then we'll code our specification. So earlier we had 3 questions, where to start, what to test, and what not to test. So we got the answers of those. Like we'll start with the user story and then break that down and go from outside to in. We are testing user stories and we are not testing anything else that doesn't fit in the user story. Given when then we just already saw in the example, given was our input, when is event, and then is the host condition where you would have your expect statement. So in BDD style of testing, in TestBox, we have all these lifecycle methods, before all, after all, run, before each, after each, and around each. And I do have an example for that. So before all and after all run, they are like global methods and they run just once. Before each and after each runs before and after every single specification in this describe block, and run is the method where all your actual test suites go. So let's just quickly look at the example. Okay, these tests okay, so again, these are just the demo tests. They don't have any real user stories, but they are mostly for demoing how do we use this lifecycle methods. So here, in my before all and after all, I'm just setting. In before all, I'm just setting this application variable which would just run once, and after all, I'm just clearing out that application struct. Then in the function run, that's where all your tests would go, and in that you can have multiple test suites. And each test suite, you can use describe or scenario interchangeably. You can use scenario word here to describe the user scenario. And then inside that, you would have these are furthermore lifecycle methods which would run before each of the expectation in this particular describe block. So here, let's say I have codebox 0 and then I'm implementing codebox to be. So when I'm just testing that, I expect my codebox to be 1. It's passing here. It's just a loader, so it can contain. So that's what it was. And then you can also have more than one expectations inside the block. It's just to demonstrate how you can have multiple expect statements or just one expect statement and stuff like that. These are not real tests. It's just to demo how can you use these kind of matchers. And then there are tons of matches available in TestBox. They are. You can also negate them. This was 2B, this is not 2B. Then you have greater than, less than, 2B type of array, not 2B type of array, anything. And that's what is demonstrated here. And then you can also have multiple describes, nested suites. So this is my outer suite, and then inside that I have another nested suite, and you can also pass dynamically data from outer suite to inner suite. So it can do a lot of stuff. If you use X in front of it, it would just skip your test. So for some reason, if you don't want to test one particular thing, you can just add X to it and it would skip it dynamically for you. So there you go. This test is getting skipped. So that's what the BDD life cycles are. Okay, now let's look into the real example. So we already saw string concatenation. Now let's look into exception demo test. So 2 takeaways from this test. First is so here it's just a simple function. I'm taking 2 numbers and dividing them. If we are dividing by 0, it will throw an exception. And then how do you test the exception? Using TestBox. And that was so let's look into the test. Okay, here in my describe block, I'm using this before each lifecycle method. So this would instantiate your CFC before each of the tests here. So before this block, it would instantiate your CFC. Okay, before this block, it would instantiate CFC. So I could also write this in before all because this is just one time thing. And it's common to all the tests, but I just wanted to demo before each, so I just added it here. You could very well write it this line in before all. That's totally accepted. So I'm testing here happy path and unhappy path. The first 2 are happy paths where it's not throwing the exception. But in the last one, it's dividing by 0, 10 divided by 0. And how do I test the exception? So TestBox has this to-throw method where you can just expect your function. So this is a closure format. When you're dividing your function, when you're dividing 10 by 0, you target a system under test, which is the CFC. It should throw the division by 0 error. So when you run it, so first two are the happy parts, and the last one is the unhappy part because it's throwing the exception. So two takeaways from this test. There in the test box, you have two programs by using which you can test your exceptions. And the another takeaway is if you have multiple logical paths in your code, let's say if you have multiple if-else statements or multiple case statements inside a switch state or try-catch and you're throwing some, make sure you test all the boundary conditions, all the happy path, unhappy path. Like if you just test it using first two, and then you just not test the third one, division by 0, you don't know whether your code works or not. So make sure it's more than code coverage, it's more of a logical code coverage. Make sure you get all the boundary conditions and edge conditions. The next one I have is customer test, customer CFC. So this particular CFC is not doing much. It just has 3 properties: name, address, email. I have update name, update address, and update email functions. It just updating your default name, address, and email. That's it. It's not doing anything much. So how would you test those functions? So it's another example of writing PDD. So this is, let's say, described as I'm testing my banking application given as my customer exists. So you're just saying, okay, this is given, but then how do you know it's really given? So that's where I'm initiating my customer. Customer equals new controllers customer name, address, and email. So that means my customer exists. And since it's in before all, it's going to be run before my tester runs. So okay, my customer name exists. Now your user scenario is when you update when basic information is given like name, address, and email, and when you are updating with, let's say, new name or new address or new update, what happens? So how would you test that? So you would just say customer.get name, get address, or get email. So getters and setters are already available. You don't have to write them by default because this is passed as a property. So getters and setters are available. So you can just test when you call update name by foobar, my get name should be foobar. So when you run that, there you go, all the tests are passing. So let's say, let's break one test intentionally. So this is my original name. And I'm updating by foobar, but I'm still expecting my customer name to be full. And that's where it's going to fail. There you go. It says expected full but received full. So that's how you can see where your tests are failing. It also gives you the line number where it fails. So it's very easy to debug. So that was another example of writing PDD. So all these are like simple examples of functions, but not all the real world life examples are simple. And we do have function dependencies. Most of the time our functions would talk to databases or file systems, or they have dependencies on another function. So at that time, how would you test your functions? And the answer to that is mocking. So what is mocking? So let's say I have function A, which in turn calls function B and C. So it depends on these two functions. And let's say when I'm testing my function A, B doesn't exist, or B has some errors inside it. Or same thing with C, C doesn't exist, or C itself is breaking. Then how would you test your function A in isolation? And that's where the mocking comes in place. So you're isolating the behavior of functionalities from all the other dependencies. So that's the mocking concept, like isolating this stuff. This is just the definition of mocking. you're creating objects that simulate the behavior of real objects. And it's a testable that stands for real implementation code during the unit testing process. So Mockbox ships along with TestBox. If you already installed TestBox, you would automatically get access to Mockbox. It doesn't have to be installed separately, it ships with TestBox. And it has mocking and stubbing capabilities. It has different mocking methods and verification methods available. You can create mock stubs using this mocking framework. So let's look into the examples. So the most important is most of the times most of the applications are one way or another interacts with databases. So how would you mock a query if your function contains a query grid? Again, this is, I'm not really interested in the nitty-gritty of what the function does, but I'm more interested in how to mock the query. So this particular function takes the input as query, and that's a required argument. And let's not worry about this, let's just see that it just returns the empty stuff, because we are not really interested in what the function does. So when we are testing this particular function, I want to have a query without reaching out to the database. How would I do that? So these 3 lines of code would do that magic for us. So Mockbox comes with the query sim method, which will simulate the query for us. So I'm just providing this particular query definition to this query sim method. And in this, let's say I have a customer table, which has customer ID, customer name, I don't know what's called. You can say joining date, or anything, and then these are the names of the customer IDs and these are the dates. So I'm just 5 characters are the column separators. So you can have as many rows as you want. You can have a few more stuff like that. So when I am calling my function foo, since it required argument query, I'm now passing this input query to it, and then I'm just the expected result was just the empty struct, because we are not focusing on what the function does right now. But let's say what happens if you run this. Okay, so it passes, but where is our query? So let me just jump to it. You can see that's query. So that's my query. So query sim method has populated this query for us with 3 columns and these data, and that is now passed to my function. So that's how you can mock the queries without reaching out to the database. The other example I have for mocking is when the collaborators are missing or not defined. So let's say in this example, let's say my function B doesn't exist or function C doesn't exist, then how would you test your function E? So example for this, check here. Okay, so this particular CFC extends to account CFC, and account CFC has functions like withdraw, deposit, and then checking account is extension of that, and it overrides those functions as well, and then it also depends on notification service, which is not yet built. Also, it has check as a required argument, whereas check object also doesn't exist because check CFC doesn't have anything yet. So when I'm testing, let's say how would I test process check? Because my check CFC doesn't have anything yet. It doesn't have functions like get amount, nothing. So how would I test the process check? scenario is when a valid check is processed from a checking account which has sufficient funds. What is your given and when here? So given is I have a customer with checking account with initial balance of $250, and when a check of $100 is processed, then the new balance should be $150. And that's here I'm initiating my checking account to have a balance of $250, and that's the mocking part of it. So since my check doesn't exist, it doesn't have methods like get amount or get check number. So Mockbox provides you with the mocking method. So using this dollar, you can really mock the results of any method. So dollar results it's just the mocking method. So I'm saying that my check's amount is $100 and my check number is 421 and when I'm calling this process check function, although this doesn't exist, I should be able to test my method, and my ultimate balance should be deducted by $100. So my ultimate balance should be $150. So what happens when I run this? That's the mocking example, and it passes. So that's the example of when the collaborators are missing, how you isolate your function. And these examples are again the examples of how would you test the functions. All this code is checked into GitHub, so you can take a look at it. These are very simple examples. Let's stop it. And the beauty of TestBox is, so this is not a CodeBox app, this is a Framework 1 app. So you can, if you don't use CodeBox, that's fine. If you use CodeBox, that's better. If you don't have to like that's fine, because you can run your TestBox on any app. Alright, so moving on. Now let's switch gears to the load testing. So, load testing is important because nowadays, if your website is slow, users are gonna leave your website and then they are just gonna possibly Google for alternatives. Or if your website is crashing on high load or peak load, it's the business loss, it's the revenue loss. So it's important to know what the peak load for your site is, and your system should be ready to handle the peak load before the bottlenecks occur in production. So for that, we can do the load testing. It's a type of non-functional testing because you are testing multiple users at the same time, and it is the process by which you can simulate the actual user load on any application or website. And we have various tools available for that. There are some proprietary tools, and then there are some open source tools. We would look at the JMeter, which is an open source tool in this, and we would create the load and then measure the user experience, like how my system behaves under the normal load or peak load, and determine various parameters like throughput, latency, or capacity of the system. So JMeter was written in Java. It was released in 1998, so it's been around for a while. But since it's open source, it has a rich ecosystem, and it still has a lot of new stuff coming up. And you can do multiple things, like you can test, it works at the protocol level, so you can test all these protocols. You can do HTTP, HTTPS testing, you can test your web services, database testing, FTP testing, and so on and so forth. There are a lot of things that you can do with JMeter. And provides with a lot of reporting tools as well. Like you can just export the results in the CSV file and have or you can have multiple graphs by which you can know what the system throughput is, or latency is. So how does the JMeter work? So JMeter works at the protocol level. It's not a browser. That's the main difference between a browser and JMeter. So when browser works, it sends the request to the server, and then the server responds with some kind of response, and then the browser will parse that response and execute the JS. But JMeter, the first steps are same, like it sends the request and then the server responds, but then it doesn't execute the JS. That's the main difference. It will still parse the response for you, but it doesn't execute the JS. It works at the protocol level. So how do we install JMeter? It's very simple. You can, since it's a Java-based application, make sure that your system has latest version of Java development kit, and you can get it from this website, or Apple website. Then for downloading JMeter, you can just go to this website and latest version. Latest version is 5.1.1, so you can just download zip file or exe file and just extract that anywhere on your system. So first of all, install Java, then download JMeter. Just unzip it wherever you want, and then launch the JMeter. You can either launch it using GUI mode or CLI mode. So if you want to install, once you install it, just go to build folder and run jmeter.bat if you're on Windows, or if you're on Mac or Linux, just make sure you run the jmeter.sh file, and that will bring up the Apache JMeter for you in the GUI mode. That's my JMeter. So this is where you would create your test plan and run the test. Let's look into the examples. So basic working is you would create your test plan, you would add multiple users, because that's the main thing. You want to simulate the users. So three things to notice, the important things to notice: number of threads, ramp-up period, and loop count. So let's say my peak load, I expect my web page to get 100 users. Then you would say 100. Ramp-up period is, let's say, 10. So at the end of 10 seconds, I would have my 100 users hitting the website. And loop count is how many times you want those 100 users to do particular action. So if I say 5 times, then I would totally create 500 requests on my application server. If you set it to forever, the test would run forever until you manually hit stop here. So that's the basic JMeter working. You just simulate the users and send out the request to server, and the server will respond. And then you can have your listeners to parse that response. So let's look at this simple example. How would you create your basic JMeter test? The first thing is you would start the JMeter, which you have already done. The next thing is you would create a thread group, where you would specify how many number of users you want to hit your website, the ramp-up period, and the loop count. Let's say I want to go with 10 users for now, and at the end of 2 seconds, I want all these users to hit my website, and I want this to happen 3 times. So this is my basic thread thing. I just set up my users. Now, what do you want to test? So I want to test my web page. So that's the HTTP request. So let's say I'm just going to test my local site here, which is this. You don't have to mention the protocol because that's already here. So I'm just getting rid of this HTTP. That's my website. So right here, the code would go here. And since this is a home page, that would be just this. Just this. So I'm testing my home page with 10 users 3 times, so 30 requests total. The next thing is I want to know the results of this test. So let me go ahead and add listeners. So let's say view results in 3. Also view results in 3. Alright, so let's just now run the test. So as you can see at the right here, tests are running. And you can see all the tests are passing, all are green. And here it just says response code is 200, that means the response was fine. It developed fine. That's my request. It's HTTP get call to this particular home page, and the response is this. So now let's say I want to validate something on this page. So for that you can add assertions. Let's say we add response assertion. So on this test page, I have getting started with framework 1. So I want to test that this particular web page responds with the text getting started with framework 1. So that's the text response. So I'm saying my main sample in response would give me this particular string. So let's go with contains. And now when we run the test, let's see. Now we run the test. Okay, the tests are passing because it contains that response. Let's say if you go with getting started. Now the test should fail because our web page doesn't have that. And there you go. You can see everything is failing. It says expected to receive this, but did not receive that. So let's add one more assertion, which is duration assertion, because this is important assertion because you want to know like how much time your web page response is. Let's say if you want your web page to respond in 20 milliseconds, and now run it. Let me just take this response assertion out. Some requests are passing and some are failing. This one failed because this ran in 6 milliseconds, but this ran in 10 milliseconds. So when your application has lots of load, you can use this duration assertion and see how your website is responding in what particular time frame your website is responding. So this is how you can test your web pages. So now let's say if I had about path, I would just say about. You can test any page by adding the path here. So that was about the basic test using JMeter. Now let's just look into the more examples of REST API. If you had REST API created for your system, how would you load test that? Since I don't have any REST API developed by myself, I'm just using Jita's web API, which is publicly available, and I'm just going to get issue and create issue one example for get and one example for lose. So this is how you would get the details of the issue. And that's my Jita setup. So let's say I have few tickets created already. So how would you test your API? So this time I'm not building it right away. I already have it pre-built. Okay, in this I have already created a thread group with 10 users hitting my REST API. Ramp-up period is 2, so at the end of 2 seconds I have 10 users. If I expand this, you will see HTTP request. In the HTTP request, I have my localhost 8085 local Jira instances set up, and then I'm just testing this particular ticket. So REST API, that was the REST API to issue and then issue ID or key. So this is how I'm dynamically passing my issue ID to my HTTP request, and the method is get. You can test all sorts of methods, get, post, get, put, options, freeze, delete, all sorts of methods. So let's go ahead with get now. And where is this thing defined now? So that's defined in my test plan. So that here's where you can define your user variables, and I'm just testing with this particular ticket. And then I do have listeners again, view results in table and read. And then the important thing here is we do have some kind of config elements available. So Jira is a login based API, so I need to have my username and password somehow provided to JMeter, and you can use HTTP authorization manager, which is available inside config elements. So config elements are to set up any defaults for your test plans. These are all the config elements. Right now we are using HTTP authorization manager, but these are some more useful ones like cookie manager or cache manager and HTTP request defaults. There are some useful ones. And the same thing with JDBC connection configuration. So that's where I have provided my login details to JMeter, and then I do again have response assertion, the my web page response with 200 page was fine, and the duration assertion and again 20 seconds. What happens when I run this now? Everything is failing because my system is responding very slow with just 10 users of load. So you can see so this is not my idea, but if we have my idea, I need to look into what is so slow, and I need to see where I can make improvements because this is very slow. The next example that I have is for post API, post method. Again, this time I'm going to just have one user posting something. For them, and the difference is now you would select post method here, and that's the path REST API to show that's how you can create the issue. This is where you are passing the body of the data. To create any Jira ticket, these are the mandatory fields. So I'm just saying this is the ticket. Again, I'm giving my username and password to JMeter. This is where I want to see the results. And another config element that I'm using this time is, since I'm passing the data in JSON format, I should tell my JMeter that my content type is an application JSON. So when I run this, it executes fine. It returns with. So this was the post call, and it returns with this particular UDP 11. So that's the new ticket that got created. You can see this ticket was created just now. So you can test your post API as well using JMeter. You can set as many users as you want. I just created one right. The next thing is how do we test the database. Since database is the important thing, if your application is performing slowly with multiple users, you need to fine tune it. And how do you test that? So I have a mariadb test database, and to test that, I just added mariadb JDBC jar to my JMeter lib folder. If you have a MySQL database, you can add MySQL connector to JMeter's lib folder. And this next things are again seen. You would create a test plan, you would add thread group where you can set how many users you want. The different thing here is now you want to tell JMeter your database configuration, and you can set that using config element JDBC connection configuration. That is my username password. That's database. Next thing is that earlier we saw examples with HTTP requests. Now this is the JDBC request. This is the database test, and I'm just testing select start from department where my departments have these values. So in my assertion, I'm just testing that I get marketing department as a result. When I test this, when I run this, everything passes. So you know that your database is running fine with 10 users. Let's see. I had one failing example as well. Employees. This particular one returns unknown. Fails. Because now I queried a different table, but I was expecting something else, so it's failed. So you can see when and where your tests are failing using these assertions. So that was for gPC config test. We already looked into what this test manager group and stuff like that. If you want to run it in CLI mode, for load testing, it is recommended that you use the CLI mode and not the GUI mode, because GUI mode is very much memory consuming. It's okay when you're setting up your test, it's fine to run it in GUI mode, but otherwise you should run it from command. And the command is very simple. You just cd into the directory where your JMeter is installed. So you would go into bin directory and then just run JMeter -n. -n tells JMeter that you have to run it from the command line mode. -t is where you would specify the name of the file of the JMeter, and -l log is the listener. So you would just get your results. And gave you the result like this is the summary. Average time taken, minimum time taken for delivers, maximum time taken, something like that. You can also format those better and export it in CSV. So some tips for JMeter are, if you have a brand new application, you don't know how much peak load test you're going to get, so you just ask your clients or business what's the peak load is going to be and simulate that load while testing. If you have existing website, you can find out from Google Analytics like how much load your website gets. Like you can get the idea like this is my peak load or this is the normal load from Google Analytics. The next thing is always you see a random mode when you are actually doing testing. GUI mode is only for setting up the initial test. Always run the JMeter on your machine because it takes a lot of memory to run those assertions and listeners. And if you have a number of users, multiple threads, then it takes a lot of memory. So at least 8 to 16 GB RAM is recommended. And make sure your load test server is in the same network. So no matter if you're hosting your sites by yourself or on any cloud, let's say you have your site on AWS, make sure your load test server is in the same subnet as your application. Otherwise, other factors like network bandwidth or latency will come into picture and you won't get the perfect results. So those are some of the tips. And these are the resources that I found useful when learning unit testing and unit testing. I'll share the slides on my LinkedIn account so you can go ahead and have access to that. And this is where all the unit testing demos on the computer.